Good morning, students. This is chemistry period, and today we have to learn about the structure of an atom. Okay, so first, Thomson's model of an atom. Today we have to learn about the Thomson's model of an atom. Okay, see, according to Thomson, an atom is similar to the Christmas pudding. See, this is a similar as like the Christmas pudding. Okay, this is a structure of an atom. The pudding had positive charge and the electron having the negative charge were like plum of the pudding. See, this is a pudding. If we consider it as a pudding, this is total, it is a positively charged, and the electrons which are there blue colored, these are electrons having the negatively charged. Okay, now an atom consists of a positively charged sphere. See, this is we considered as this is as a positively charged total sphere. Okay, and the electrons are embedded, that is electrons are embedded here and which are negatively charged. The negative and positive charge are equal in magnitude. Both, see, consider, these are positively charged and here is a negatively charged, both are equal in magnitude, so the atom is a as a whole is electrically neutral. See, this is a positively charged sphere, is positively charged, and these are electrons are embedded here, that is are negatively, both are attracted and they are neutral. ये क्या हो जाता है फिर न्यूट्रल, पॉजिटिव एंड नेगेटिव combining and get neutral. Okay, now see the image. See, we considered it as it is a image of the watermelon. It is image of the watermelon, and this part is a positively charged, and these seeds are the negatively charged. These seeds are negatively charged and which are electrons, and this plum is a positive charge and the seeds are containing are negative and both are attracted and get neutral. दोनों अट्रैक्ट होने के बाद क्या हो जाएंगे न्यूट्रल, सो दैट द एटम विच इज अ न्यूट्रल. Okay, got it? Now this is all about the Thomson's model of an atom. This is all about the Thomson's model. Now next is a Rutherford model. Now we study about the Rutherford model of the atom. See, the Rutherford, we also call it as a Rutherford's alpha scattering experiment. So Rutherford allowed a beam of fast moving alpha particles. See, these are alpha particles. From here, these alpha particles are moving on the gold foil. The Rutherford using the gold foil, okay, having the positively charge to fall on the gold foil. See, रुदरफोर्ड ने क्या यूज़ किया है अल्फ़ा पार्टिकल्स को अलाउ करने के लिए. रुदरफोर्ड यूज द गोल्ड फॉइल. ओके, he selected the gold foil because he wanted as a thin layer as possible. Because उसे बहुत ही thin layer चाहिए थी, so that's why he uses the gold foil, and the alpha particles allowed to pass over the gold foil. And also the alpha particles are having the considerable amount of energy. Okay, अल्फ़ा पार्टिकल हैविंग द मास इज़ अ 4 यूनिट. अल्फ़ा पार्टिकल जो है उसका मास होता है 4 यूनिट, एंड ऑल्सो इट हैविंग द कंसिडरेबल अमाउंट ऑफ एनर्जी. ओके, in remember one thing, Rutherford containing the gold foil, because why he chooses the gold foil, because he wanted as a thin layer as possible, because उसे बहुत ही पतली लेयर चाहिए थी, that's why he uses the gold foil. And alpha particles which having the particles having the mass 4 unit, that is 4 atomic mass. Okay, and alpha particles having the considerable amount of energy. See, next one. First, most of see, this is all about the Rutherford model. See, these are the gold atoms. See, these are the gold atoms. Okay, and these are the alpha particles allowed to move from the gold foil. Okay, and see, some of the alpha particles are moving straight. कुछ alpha particles straight move हो रहे हैं. Okay, some of the alpha particles are undeflected, that is move in a different direction. Some of the alpha particles are reflected, move backward. Okay, see, we just read first one. Most of the alpha particles pass straight through the gold foil. See, if we consider this as a gold foil, the alpha particles are come from here. See, if we consider this as a gold foil, alpha particles are come from here and they are moving straight. That is this first point. Particles are passed straight through the gold foil. Now move to next point. Next point, that is some of the alpha particles were slightly deflected by small angles. See the first image. If we consider this as a gold foil, the alpha particles are moving from here and they are slightly deflected. ये क्या हो रहा है? Slightly deflect हो रहा है. Some particle are moving straight, some particle are slightly deflected. Now third point, very few alpha particles are appeared to rebound. See, these particles are appeared to rebound, that is are reflected. ये जो particle हो रहे हैं ये return back, that is we called it as a rebound. We called it as a rebound. Some of the very few alpha particles are rebound from the gold foil. Okay, see here, these are alpha particles are moving straight, these alpha particles are deflected, ये deflect हो रहे हैं. ओके, एंड दिस अल्फा पार्टिकल्स आर रिबाउंड, ये जो है ये रिबाउंड हो रहे हैं. कुछ अल्फा पार्टिकल्स जो है वो रिबाउंड हो रहे हैं. नाउ नेक्स्ट, सी हियर आर द कंक्लूजन फ्रॉम द रुदरफोर्ड अल्फा स्कैटरिंग एक्सपेरिमेंट. हियर आर सम conclusions. Okay, now what are the conclusions? Most of the space inside the atom is empty. See, if we consider as a atom, okay, here is a nucleus, these are the orbit and having the electrons. The most of the space in the atom is empty. वो जो बहुत सारी space होती है atom में वो empty होती है. Okay, why? Because most of the alpha particles pass straight through the gold foil. See, these particles are passed straight through the gold foil. That's why most of the space in the atom is empty. Okay, now next point. The atom had a small nucleus having positive charge. If we considered as an atom here, it is a small nucleus and having positive charge and having the positive charge. Why it is happening? Because some of the alpha particles having positive charge were slightly deflected. See, this is a gold foil, ये हम consider करेंगे gold foil, and some of the alpha particles are deflected from here. So that's why the nucleus having the positive charge. Okay, now next, the size of the nucleus is a very small as compared to the size of atom. एटम के साइज से अगर हम न्यूक्लियस का साइज कंपेयर करेंगे, सो एज कंपेयर टू न्यूक्लियस, एज कंपेयर टू द एटम, द साइज ऑफ न्यूक्लियस इज अ वेरी स्मॉल. बट वाई दिस इज हैपन? बिकॉज very few alpha particles appeared rebound. See, this is a gold foil if we considered, and these are alpha particles and some of the alpha particles are rebound. कुछ rebound हो रहे हैं. That's why the size of nucleus is a very small. Okay, these all are the conclusion of the Rutherford alpha scattering experiment. These are the conclusion of the Rutherford alpha scattering experiment. Now the Rutherford's model of an atom. Actually Rutherford का atom model जो है atom का, what are the points? Okay, so see what are the points in the Rutherford model of an atom. An atom has a positively charged nucleus and its center, and most of the mass of atom is in the nucleus. See, it is a nucleus having the atom and positively charged. These are the orbit and having the electron which are negatively charged. Okay, which are the negatively charged. Now the electron revolving around the nucleus is in a different orbit. See, it having the different orbit and these electrons are revolving in a different orbit. अलग अलग orbit में electron revolve होते हैं around the nucleus. Okay, in an atom around the nucleus the electrons are revolving in a different orbit. अलग अलग orbit में electrons revolve होते हैं. Okay, the size of an nucleus is a very small as compared to the size of atom. Yes, this point is correct. The size of the nucleus is a very small because as compared to the size of the atom. Why this is happening? Because the most of the particles, alpha particle जो होते हैं वो rebound होते हैं. That's why the size of the nucleus is small as compared to the size of the atom. Okay, now here we stop. Okay, in next class I will one more time explaining the Rutherford model of an atom, and we go to directly to Bohr's model of an atom. Okay, so here we stop.